if you're interested in structured knowledge, you've come to the right place, because that's what I'm really into, very, very deep. So I'm going to tell you what I've learned about structured knowledge and what I've been doing. So what is structured knowledge? Let me start off by saying I come from a background as a database programmer, and I do artificial intelligence development. And I had this idea, what if we could take knowledge that's in like books and articles, things like that, and somehow break it apart and store it in a database. So like when I say database, I mean like a Microsoft SQL Server, a Postgres, Oracle, anything like that. And I'm not talking about storing it like the raw text. I mean breaking it up into some structured knowledge, structured format, like JSON is a structured format, for example. CSV, XML, those are all structured formats. But I was thinking, what would be the ideal structure for that? And you may be aware of RDF is one attempt at breaking everything into structured format. I looked at RDF and rejected it because it has some limitations, which I'll go into later, I expect. But let me say what I eventually arrived at is the discovery or realization, recognition, awareness that the optimal structure for knowledge is a hub and spoke format that's something like a bicycle wheel. So I call it a hub and spoke file format, HFF, or more simply, I'll call it a synapse, like the synapses in our brain. And I'm going to tell you all about the hub and spoke file format and synapses, and tell you about the journey I've been on. So it all goes back to what I see as a big weakness in AI, and that is with AI, the industry, tech industry is trying to bake more and more knowledge into the LLMs and make them bigger and bigger, and that's a good thing. But at the same time, it's not reliable. I'll give you a couple examples. Like recently I asked one of the big name AI web pages that you'd know if I gave the name. I asked it, who wrote the words, "I know more than a novice in a nunnery"? Now that's a song from Gilbert and Sullivan, the Major General song. Look it up, it's a great song. But it said, but I couldn't remember at the time, where is this from? And it said, oh, that's from William Shakespeare, Romeo and Juliet. And it said it very confidently. And more recently, I asked the same AI, and this is an AI system that has a big search engine behind it. So it's able to do web searches to front load the LLM with some information it's harvested from the search database. And so I asked it about Gene Wilder, who was in the movie Willy Wonka and the Chocolate Factory. And I was asking it about his filmography, and he said, oh, he's in the movie Russia House with Sean Connery. So again, it's kind of funny, but kind of funny like a crack in a bridge is funny. If you can imagine you're like a lawyer and you're using one of these AI systems to help you file the documents that you're going to prepare, the documents you're going to file with the clerk of court, citing legal precedents and laws that are on the books, and it hallucinates things. So experiences like this made me realize that the LLM really needs to have an external source of knowledge and not just things it pulls off the web. It needs to have a carefully curated source of knowledge, and I've come to calling those knowledge packs. So like imagine a system where we've got knowledge packs that are specific to like legal, medical, and maybe even more specifically like a knowledge pack of criminal laws of the state of Louisiana. I'm in Louisiana. Civil laws of the state of Louisiana, laws of the city of New Orleans, offshore drilling laws, things like that. So I can imagine an ecosystem where there's going to be knowledge packs in structured knowledge that we can download and then connect our AI system to it. So when it has a question, we go to this structured knowledge, it pulls it out, and it's able to, in that structured knowledge, cite exactly what's the provenance of that information. By provenance, I mean, where did that come from? Okay. So as I started looking into structured knowledge, and you may be aware of knowledge graphs, like Neo4j, for example, is a big knowledge graph product. And I looked at how would we get knowledge from documents into this structure that I call the hub and spoke file format. And that led me to an awareness that somebody, which turned out to be me, needs to program a process that automates that. So I've built a process that will take prose, like raw text from documents, could be like a PDF document or a docx. Docx is like your Microsoft Windows Word document, and burst it apart into individual sentences, and then from each sentence burst that apart into the components of that sentence. And sometimes a sentence may be very complex with a lot of clauses in it, subclauses, and so you need to break it down to the most granular level of the clause and then extract information from it. Now, the thing about RDF I mentioned earlier is that it tries to fit everything into what I think is a rigid format of subject, predicate, object. Subject, predicate, object. And that works for a lot, but not everything in language. And there is a problem with putting the predicate in the middle. And everything is a triplet, subject, predicate, object. As long as it fits that pattern, it's going to work with RDF. And so I started looking at alternatives and came up with this hub and spoke format that puts the verb in the center. Like on a bicycle wheel, the center is where you'll put your verb. And then the spokes around it will be all the other things in the sentence. And then there'll be a relationship between what's in that verb and these things around it in the sentence. And with that, I came, just a lot of thinking, I came to the conclusion that the best kind of relationship between the verb at the center of this format and what's out on the end of the spokes would be what's called thematic roles or thematic relations. So if you Google that, look on Wikipedia, look up about thematic role theory. It's also known as theta, Theta, and it's this theory, which I believe is correct, that you can take any kind of clause or a simple sentence and break it up, and there's going to be some roles in that, some role playing, like who is the actor? The actor is who is doing the action. Who is the recipient of that action? So we call that the patient. So there's an actor and there's a patient. It's not necessarily the who, meaning the human. It could be the what. So we've got an actor and a patient. But we've got other kinds of relations between the verb and the thing that is the target of that verb. And that can be things like what's the reason or the purpose for this happening. It could be the time. What's the time this is happening? It could be, we talked about reason, the attribute, an attribute of something. So for example, we're talking about a strawberry. We could say a strawberry has an attribute of color being red or taste being sweet. So those are examples of attributes. So this hub and spoke file format beautifully maps out the relationship of these things in this, it's like a crystalline structure, like the bicycle wheel, that ties them all together. And so that's the most atomic way of representing information in the most granular form. So I like to think of it as like atoms. But not everything, some things, some information is very atomic. Like if you're looking at a Wikipedia article about someone from history like Ludwig van Beethoven, and you can have a lot of atomic level facts about him. You could say Ludwig van Beethoven was born in December 16th, 1770, or was born at Bonn, Germany. Okay, so these are very atomic, but there's other kinds of information where it really doesn't stand alone very well as an atom. It's not meaningful. It's the other atoms that are joined to it, almost like molecules, that gives it meaning. So this structure that I arrived at, I realized needed a way to group these atomic facts so that multiple atomic facts that are related could be grouped together to form a logical whole. Whole, W-H-O-L-E. And so I'm calling these little kernels, atomic kernels of facts, I'm calling them synapses, as I mentioned earlier. It's kind of a shorter way than saying hub and spoke every time, okay? So synapse groups is where I would group multiple of these together. Now, if you're interested in learning more about this, I just published 6 books about this, this method of organizing knowledge into synapses and synapse groups, so that then it can be put in a database and queried and then feed into an LLM when it's transforming knowledge from one form to another in response to answering a question, that sort of thing. And you can find these books on Amazon, and if you look for my name, I'll put this in the link on the video down at the bottom, so you'll be able to just find that link and click through. Now, I'm not trying to sell the books. I give the books away free in PDF form on my GitHub repo. I have a Git repo with all the books. They're free. The reason they're on Amazon is just if you happen to want to get a hard copy so you can hold and look at on the plane or whatever, so you don't have to always be looking at a screen. A lot of people like to have the book to hold. But I'll tell you about the books. The first book is sort of an overview of the whole system, and I call it The Napkin Pitch. And it's told in story form, like the Socratic method of teaching, where you have like a novice and a teacher. The novice is asking questions, the teacher answers the questions. So I kind of took that method, except it's not a teacher and a student, it's just people in a modern business environment in San Francisco having conversations about what's the structure of knowledge. So it's sort of an introduction to the whole 6-volume book series, and it's called The Napkin Pitch. And I call it that because it's like the first scene takes place in a restaurant after working hours, and someone's trying to explain to someone the structure of knowledge. So they take a napkin, and their pen out and write on the back of the napkin, write on the napkin, sketch out the diagram. So I call it The Napkin Pitch. The next volume in the series is called The Architecture of Meaning, and that gets into this whole hub and spoke file format. And it also describes how we get the information from like books and articles and corporate documents into the hub and spoke file format in your knowledge graph. And that's a process that I call GLEAN, G-L-E-A-N. That's an acronym for something that I don't remember exactly at this moment what I was thinking when I made up that acronym, but I just call it GLEAN. You're gleaning the knowledge and putting it into these atomic and molecular forms in your knowledge graph. And so that's the next book. And it also talks about, in the Architecture of Meaning, about a lexicon. So we want everything in our knowledge graph to point back to some like dictionary, so that machines can look up see a word in the knowledge graph and connect instantly to a dictionary to see what does this word mean. And so what I'm using is, there's a free open source dictionary or lexicon, kind of means pretty much the same thing, lexicon dictionary, called Wiktionary by Wikipedia. Okay, and it's got 1.7 million terms in it. And so everything that we're pulling into this hub and spoke file format, all of the points of information in the hub and spoke file format I call nodes, N-O-D-E-S. Like in knowledge graph, you have nodes and edges being the relations. Okay, so every node is going to point back to the lexicon. And so we've got a free open source 1.7 million word or term lexicon that anybody can use. It's free, open source. You can use it for for-profit purposes, corporate business purposes. Make a product out of it. You don't need anybody's permission because it's the licensing is open source. And so I realized we don't need to have like some international standards body deciding what every word's going to mean in our knowledge graph if we just agree to use a common, readily available dictionary like that. Okay, so that's all in the book, The Architecture of Meaning. The next book is called The Third Protocol. And the idea in that is once you transform your information from the raw prose into structured knowledge, wouldn't it be neat if we could get machines to communicate with each other, like machine A sending a message to machine B using these synapses and synapse groups to structure the information. And so I realized we need a protocol for machines to communicate. And so what I came up with is a JSON, J-S-O-N, file format that in which you have these synapses and some things around that help the machine B know when machine A is talking to it that it really is machine A and not someone impersonating machine A, and that machine A is the machine that machine B is going to trust. So all the trust certificates and signing and all that is part of the protocol. So I call that the HFF wire protocol, HFF, or the hub and spoke file format. And then there's another layer that rides on top of the HFF wire protocol, and that's called AFP. And AFP makes declarations of what's in this message. Is it a request for information? Is it a command? That sort of thing. Okay, so that's the book called The Third Protocol. Why do I call it The Third Protocol? The idea there is that TCP, upon which the whole internet is based, was the first protocol. HTTP, by which makes possible web browsers and web pages, was the second protocol. And so what we have here now, so that machines can communicate with each other using structured knowledge, I call the third protocol. And well, machines are already communicating with each other. You may be thinking, what are you talking about? Well, what's special about this protocol is it makes it possible for machine A and machine B to communicate with zero prior integration. They don't need to have custom programming. If they both speak this protocol, then they both can communicate and know what the other one is meaning exactly, because every message has these nodes that tie back to a shared lexicon. And so the machine can navigate from a node and find out what every word in the lexicon is pointing to by an ID that points to the row in the lexicon. So that's the book called The Third Protocol. And I'm going to come back and say something about how we connect the lexicon to our synapses. The fourth book, is called Omega, the Governance Language. And it's a book about how we have governance over machines, which could be robots, it could be chatbots, or just agentic machines running AI that are making decisions. So we need to have a language for rules to tell the machine, here's what you can do, and here's what you cannot do, and here's what you may do. And so there's like 13 primitives in this language that I call Omega. And the Omega language, the synapses, the wire protocols, they're all on my Git repo and expressed in formal RFC, that's a request for comment, RFC format. And I'll put the links to that. And then there's two more books in the series that describe once you have knowledge in a structured format and you've got machines talking back and forth and they've got a governance layer operating on them, wouldn't it be interesting if we could build a smart operating system on that? And so I came up with this idea of a operating system that's running as another layer in the layer stack here that has a very small, simple, stable kernel, and the complexity is all done by natural language to guide the operating system. And I'll talk more about that. So that's the fifth book. The sixth book is also about this AI operating system, and it's about giving the operating system a constitution to guide it so that it knows what to do when it's outside of supervision. So in the book, it gives this example of imagine a deep space probe that's going beyond our planets and out into space, and it encounters things that the programmers didn't anticipate, so it needs to make decisions. And if these are recurring problems that it's facing, then it needs to have the ability to write its own laws. But to write its own laws and keep it within constraints of how we would want it to behave, we need to give it a constitution. So that's what the final book is about. So the fifth book about the small stable kernel of the operating system is called The Grounded Mind, and that final book is called The Sovereign Machine. So it's operating with sovereignty out on its own, but with a constitution that governs it. So it's a 6-book series, and I'm going to be talking about each of these in some more videos. And something I'd like to go back and talk about now is the lexicon. So I told you that to make these synapses work, it's not going to be it's going to be a bad thing if we have ambiguity. So words can mean multiple things, and I'll give you an example. The word bank, B-A-N-K. It can mean, obviously, everybody knows it's a place you store your money, a business where you store your money, or you go borrow money, get a loan for a car or a mortgage. But bank could also be like the side of a river, the side of a creek, the creek bank, the river bank. A bank could be an aeronautic maneuver that a plane performs. And I looked in Wiktionary, found there's actually 40 different independent meanings for bank. So when we put the word bank in one of the nodes in our knowledge graph, it's not going to work to just put bank. When we start searching, navigating through this, it's just going to be chaos. And imagine all the words in the English language having so many different possible meanings. So I came up with this idea of creating a unique identifier, a key that includes bank, and the primary word entered in a dictionary is called the lemma, L-E-M-M-A, the lemma. And so when we have variations on word that adds like past tense, plural, possessive, and all of that, like banking or banks, plural, banking being past tense, etc., or banked. I guess banked would be past tense. So we want to know what's the core root word in that. And so all of those have in common B-A-N-K, bank. And so that's called the lemma of the word. So the entry in a lexicon or dictionary is always going to show the lemma. Okay, so we need a unique identifier that shows the lemma of whatever word we want to put in our knowledge graph, but then some disambiguator. And I came to the realization that if we had a string where we show the lemma, and then we have a delimiter like I used a period or a dot, and then the definition, then that would totally disambiguate it. But the definition is too many words. It can be a sentence, several sentences. And so and they call that a gloss, G-L-O-S-S, in the world of dictionaries, the gloss, like we get the word glossary. So I came up with the idea we need a microgloss. So we don't need a 2-paragraph definition of a bank. We just need 2 or 3 words, maybe 4 or 5 in some cases, to disambiguate the use of that lemma from every other word that shares that same lemma. And so when we pair the lemma bank with the words like save, borrow, business, or business, save, borrow, then we know, oh, this is financial bank. If we pair bank with the words water's edge, then we know, oh, okay, yeah, this is the side of the river, side of the creek. Aeronautic maneuver, we know, oh, okay, that's banking like an airplane banks to the left, banks to the right. Okay, so I call this a microgloss, and it's sufficient for a machine. It's also sufficient for a human to look at that and see, well, okay, now I get the sense by looking at this key what kind of bank it is. Okay, and the neat thing about this this key, where we have combined the lemma with a microgloss and some delimiter between them, and you're probably going to want to also have another period or dot as a delimiter and have the part of speech, meaning part of speech like, is this a noun, is it a verb, adjective, adverb, that sort of thing. Then this becomes a very portable, unique key that's both globally unique and totally disambiguates from every other sense of the meaning of the word. And so it has another neat property, and that is with embedding. Embeddings where we take some string of words and we identify its space in multi-dimensional vector space, okay, like 1024 dimensions, for example. Then we know we have a mathematical way of showing where this concept is in, when I say multi-dimensional, I mean like imagine an XY axis on a Cartesian coordinate system. That's a two-dimensional vector. Now imagine for meanings of words, we have 1024 different axes on our graph. Okay, so every concept, every word can be mapped to this high-dimensional vector space and stored as a number, and we can store that number in like a database or a file. So the neat thing about these IDs, where we have the lemma and the microgloss and a part of speech, is we can embed it, and then if someone else has some meaning that they use this same representation, but their microgloss use a little bit different wording, if they embed that, we embed ours, then those embeddings will match up, and then we can, if there's some similarity maybe to some synonyms that are closely related, we can further filter that out by just controlling by filtering on the lemma. So that's a neat thing about these IDs, and I call these IDs canonical ID. Canonical, C-A-N-O-N-I-C-A-L, I think that's spelled, canonical ID. So the way this architecture works that I've been describing is you start out with downloading the free Wiktionary lexicon, and then you run a script, and I have the scripts on my Git repo that will assign the microgloss and the canonical ID for every one of those 1.7 million terms. And then there's a process where you ingest, you transform your documents to these synapses, and then loads them into the database for you. So then you can query the database and find factual information. Now there's some other things that I want to talk about that Glean does and what it doesn't do. I guess I'll start with what it doesn't do, and that is what it doesn't do very well. Poetry is not really a very suitable genre for Glean because it's so, it can be so heavily laden with metaphors where it just doesn't map very well to factual type information. In poetry, you can really say anything you want. Also, stream of consciousness, like some of the literature, like the novel Ulysses, where it's just really far out there, doesn't really map well. What maps the best is documents that are very high density of facts, like Wikipedia articles. It's like every single sentence is very dense with facts, okay? A novel, a piece of literature, a novel, story, probably doesn't map very well because novels aren't always, it's not this that they're not factual. Fiction would be all right. It's that the author is often creating ambiguity and withholding information and only like revealing things piece by piece, like pulling back the layers of the onion one layer at a time. So like in a novel, imagine you see someone who's across the street and they're getting in a car. The person assumes, oh, they're getting into their car. But later we realize that's not their car and that's not their house either. You learn these things gradually, bit by bit. That's how the genre of story is. You learn things gradually. Now, if you took something in that genre and you pre-processed it through an LLM, a large language model, to have it extract things and reformat it into facts, sequence of events, information about the characters, the events, the locations, things like that, that would process very nicely through Glean into extracting into Synapses. So that's what you have to do with some genres of information is pre-process it. Okay, so I just didn't want to give the impression that it's just going to take work just perfect with every form of information. It works really good with very high density of facts. Okay, now some other things that it does that are good is that it using the assistance of a large language model to interpret what's going on in the sentence. It looks to see, is this spoken or written in a straight factual form, or is the person speaking or writing using hyperbole or sarcasm or irony? So like some of those forms, like hyperbole, you're going to say something exaggerated, like, I'm so hungry I could eat 10 pizzas. Okay, so we don't want an AI system that's connected to DoorDash to order 10 pizzas from Domino's to be delivered to you. It needs to be able to recognize this is hyperbole, exaggeration. And some forms like sarcasm or irony will say the exact opposite of what the intended meaning is, okay? So we need the assistance of a language model as we're processing things with Glean to look at it and determine what I call the rhetorical mode. So all of these synapses we're pulling in, we want to know the rhetorical mode. We also want to know some things about the point of view. So like who's speaking or talking here. Because sometimes facts can exist that are inconsistent, but it's important to have both of these inconsistent facts in our database. So Glean is not looking for what is the truth of the universe. It's just looking for what is the truth in what's being stated here. So it's more like a court reporter, just writing down what it sees. So for example, imagine a court document in some court case where we have a statement from a witness that says, the car was driven at an excessive rate of speed and did not appear to slow or brake before impact. And we would tag that with the point of view, which is witness number one. Defendant may say, oh yeah, I was going the speed limit and I braked just in time, but there was no way I could have avoided it. Okay, so we have two conflicting facts. So we can have conflicting information stored in the database that's totally inconsistent, but if we flag it with what's the point of view, then we're fine. It's also, I'll give you another example. There was a famous pianist named Vladimir Horowitz. For decades through his career, all of the program notes and biographies mentioned his birth year, and it was only late in his life that it was later revealed that no, actually he was born a couple years earlier, but his father had changed his age to help him avoid military service. Now, he lived in Russia during the time of the Russian Revolution and World War I and all that, and so it helped him avoid very possibly death there. And so the point I'm making is that facts can exist and the whole world accepts them as true, but later we learn, no, it's something else. Well, we probably want to record inconsistent facts in our database, in our knowledge graph, but if we show what's the provenance, what's the source of this fact, then they can coexist side by side, and it's not really a conflict. We're just having the system operate, like I said, a court reporter, not trying to sit in judgment on what's the real truth of the universe here. Okay, so Glean does these sort of things. Glean also works to find out what is the like the verb dimension. So with verbs we have tense, like is this past tense, future tense, and aspect and mood, and I won't go into all of those. There's actually 41 dimensions associated with verbs. In high school, I know we just learned like basically tense, is it past tense, future tense, that sort of thing. But linguists have identified there's actually 41 different dimensions with verbs, and so Glean will map those with the assistance of a large language model as it's processing each sentence. And then another thing that I mentioned earlier is that these atomic facts sometimes can exist in isolation of each other and make sense without needing the context of other facts around them. So I gave you the example of Beethoven was born on December 16, 1770. You can take that fact anywhere and it's going to make sense. It doesn't need the other facts around it to make sense, but some facts really only make sense when the other facts in their proximity are joined with them into groups. And so the Glean process identifies these groups. Another thing that I want to mention is it's automatically looking at everything that's in the sentence and mapping it to the lexicon, those canonical IDs, so that as it bursts this sentence into these nodes that go into the knowledge graph, it needs to find what's the canonical ID with each of the nodes. But interestingly, not everything in your documents is going to be found in the Wiktionary lexicon. Things that are very specific, like names of individuals, people, names of companies, things like that will be in your documents that aren't going to be in the dictionary. And so the Glean process identifies those and automatically adds these as dictionary entries, but it's not going to put it in the Wiktionary lexicon. It's going to create a miniature or a micro lexicon beside it that has the same structure, same format, but it's assigning canonical IDs to these. Now, I told you that the canonical ID has a lemma, it has a microgloss, and it has a part of speech. There's another object in it, and that's called namespace that comes at the end. To fully disambiguate it, we need to know which of these lexicons it's in. Is it in the main core lexicon that everyone around the world shares? Or is it in one of these miniature lexicons that you're building dynamically on the fly? So you're going to want to have this lexicon for the miniature lexicon for terms that are specific to your business, your industry, or domain. You're going to want to have this micro lexicon for terms, words that are unique to your collection of documents. Some people say corpus, your corpus of documents, or even to an individual document. So you can have different layers of lexicons and give them unique names so that it fully disambiguates not only the lemma, the microgloss, the part of speech, but also which of the lexicons it points to. Now this namespace can be further expanded to include information that points to your organization. So if you're sharing knowledge with other organizations, they might have a micro-lexicon that has the exact same name as yours, and so to further disambiguate it, you'd want to append something that shows your organization, an organization identifier. There's also a prefix to the canonical ID for your language code using the ISO language code, like EN for English, ES for Spanish, like that. And also regional dialect as part of that language code as an optional thing. So I think I've given you the big picture. I'm trying to think now what else I could add. I'm going to be making some more videos and going much deeper in this, but in this video today I just wanted to give you an overview about, I didn't tell you what I call this. I call it the symbol grounding framework. Symbol, like, not like symbol, like you crash the cymbals. Now this is a symbol like symbolic. S-Y-M-B-O-L. Symbol grounding framework. I call it SGF for short. SGF, symbol grounding framework. And why would I call it symbol grounding framework? There's a theory that's been floating around since about 30 years ago that it's impossible to ground symbols, and it's called the symbol grounding problem. And it goes like this. It says to explain the meaning of some symbol, you've got to use another symbol. But to explain the meaning of that symbol, you've got to use another symbol. And so on. It never ends. And so the idea is there's no end to this, and therefore symbols can't ever be grounded. It's an impossibility. And as I thought about that, a couple things come to mind. I believe it's a fallacy. I very much strongly believe it's a fallacy, and I'll tell you why. There's a, I don't know if the right word is paradox. There's an idea called the infinite regress fallacy or paradox that says, like, if I try to prove something to you, okay, why would you just take my word for it? I've got to offer, or if I make some statement, why would you believe that? I've got to offer proof. But to prove something, if I prove A, I've got to use B to prove A. Well, how do you know B is true? Well, you need C to prove that B is true, and you need D to prove C is true. So this is called infinite regress. It just goes on and on. So the symbol grounding problem is just the infinite regress paradox redux. And think about this. If symbols cannot be grounded, well, math is symbols. So how do we know we can trust math? Well, we follow it until we reach things that we can't prove. We just accept as, well, this just makes sense. We call those axioms. Physics depends on symbols, but, well, if we can't believe symbols can be grounded, why would we get on an airplane and go up in the sky? So it's my belief that the symbol grounding problem is a fallacy. And so, yes, I do ground meaning in this system with the synapses and the lexicon, and it's done this way. Every meaning in the lexicon is really has some parent meanings, and those parents have parent meanings, of which the meaning is a child. And I'll give you an example. If we take the word wagon, what is a wagon? A wagon is a container mounted to a platform, mounted to an axle with wheels and a hitch so it can be pulled by an animal or a machine. It's a mouthful to say all those words, so we just say wagon. And when you think about it, you come to realize, well, all the words we use are really like shortcuts, okay? And our whole dictionary is just shortcuts. And if you realize a shortcut is taking words and compressing them into one word, then it should be reversible. You should be able to go the other direction, okay? So the parent words, as I would call them, the parents of a child word wagon, are going to be things like container, platform, wheels, hitch. Okay, so we're mapping the ancestry. And if we map the ancestors of those ancestors and the ancestors of those ancestors, we get lower and lower to more primitive words. There is a ground. Eventually, we get to words that you cannot define those words by any other words. And the linguists call this semantic primes, like prime number. Like 5, you can't divide by any other number by 1. 7 is a prime number. We have the same thing in language, prime words, and the linguists have identified there are 65 prime words or concepts that are in every language they've studied. It's universal. So if we build this map, it all grounds down to the 65 primes. So there is a grounding. Okay, so the symbol grounding framework leverages that so that we can say we've reached ground, and we can build maps so that machines can navigate. And I'll be explaining more about that in some future videos. Just wanted today to give you some overview of that, but that's how I came up with the name, the symbol grounding framework. And grounding symbols and meaning is so important so that large language models can, as we're working with them with our knowledge graph, we can have something that is something that the machine can look at, look up into and see, well, this is what this word means, and if necessary, navigate further down to ground to find out, well, what does that word mean? What does that word mean? Do you see? And as we're building these micro lexicons that are specific to things unique to your business, your industry, or your documents, those can be linked to the main corpus through these, this idea of parent-child mapping of words. So everything, as we're dynamically building these micro lexicons that help explain what's in a document, can be mapped ultimately all the way down to the prime concepts in the language. And so I want to thank you for listening. I'm going to wrap it up now, and I'll be putting some links on the video that links to the books on Amazon. As I said earlier, you can also get them free on the GitHub repo, and I'll have the path to that. You can download them in PDF form. There's some essays on the repo. There's code, and I'll be posting more things in coming days and weeks, and look forward to making a relationship with you. I'd very much like to chat. If you ever want to just post me a comment, or you want to just talk, do a Teams video, whatever, be happy to do that with you. This is what I do, is just deep into structured knowledge. And I want to say thank you for, if you made it this far through the video, you must be very, very interested in structured knowledge. And I want to thank you for being here with me.